Welcome to Section 5B. Should you believe a statistical study? We're going to go through 8 different guidelines on whether you should or shouldn't. Guideline number 1, identify the goal, the population, and the type of study. Our first example is researchers gave 100 participants their horoscope and asked if it was accurate. 85% said yes, it was. And they concluded at the end of the study the horoscopes are indeed valid. Well, let's identify the goal. If horoscopes were accurate, but the type of study was experimental, and we learned in Section 5A that experimental studies need to have a control group. And this experiment talked nothing about a control group. So it needed to have some real horoscopes and probably some fake ones. And then because they probably asked if it was accurate, there was an interaction between the participant and the experimenter, so it should have been a double blind. If they had done a poll or a small survey, then it could have been a single blind. But in the end, the results are absolutely meaningless because they didn't have a control group. Guideline number 2, consider the source. Are they being funded, or is there something else fishy going on? Is there any possibility for bias? Our first example, a study shows there isn't danger in smoking, and it may even have some benefits. The study was done by a Tobacco Research Institute funded by tobacco companies. Is there a potential for bias here? Well, there might not be a bias, but the potential is very high, and it seems awfully fishy and is contradicting all other research. So often we hear in the news, a recent study shows, and it contradicts even common sense. Guideline number 3, look for a bias in the sample. There's 2 different types of bias that we go through, and that is selection bias and participation bias. Selection bias is where a sample is selected in a way that it isn't representative of the population. So in our example from 5A, if you watched the video, we talked about this, the LDS families who were prepared with the 72-hour kit. So one way to make sure that the sample was not representative of the population, we could have picked all of our 1,000 families from Salt Lake, Utah, or just Utah in general. That is unrepresentative of the population of LDS families because we are a worldwide church and it needs to be representative of the population. Another quick note, the sample also needs to be large enough to be representative of a certain percent of the population as well. If you only ask 5 families, that's kind of silly in the LDS religion. But if you were asked 5 families on your street, maybe that is a good sample size. If your study was to ask about something just in your neighborhood. The second option, or potential for bias, is participation bias. This is when people actually choose themselves to participate. People who choose usually have strong feelings on an issue. Our first one is a case study. In 1936, the Literary Digest poll chose a sample of 10 million people on various phone lists and country club lists. 2.4 million returned the ballot, and the results were 57% said that they would vote for Landon versus 43% for Roosevelt. It sounds rather significant in the sample size, 2.4 million. However, when the election results arrived, Roosevelt won with a 62% lead. Let's look at what went wrong here. They selected 10 million people, and 2.4 million was a large sample size, but these were selected through phone numbers and country clubs. In 1936, it was a very different time. Nowadays, if you were to get a list of phone numbers, then sure, it would be rather representative of the population. But in 1936, only the wealthy had telephones, and only the wealthy belonged to country clubs. And the wealthy were more likely to be Republican and thus voting for Landon. So even though we had a 2.4 million sample size, the results are absolutely meaningless because it wasn't representative of the population. The next one is a self-selected poll. Nightline asked if the UN headquarters should remain in the US. Viewers could respond by calling a 900 number and then be charged a subsequent 50 cents. 186,000 people responded, and 67% said that the UN should move from the United States. Another simple random sample of only 500 people was conducted, and 72% of them voted that the headquarters should remain in the US. Which study should you believe, and why was there such a difference in these results? Well, the first one, the 900 number, they were charged 50 cents, which means these people who responded had very strong views. Of the 500 people, it was a simple random sample, and therefore there wasn't any bias. So the first study suffered from a participation bias. And so the second one, even though it had a much smaller sample size, it was a better representation of the entire population. Let's go to guideline number 4. Look for problems defining or measuring the variables of interest. The variables of interest are the items or quantities of the study that you're seeking to measure. In a survey of 1% of the wealthiest Americans, they stated they would pay $487,000 for true love, $407,000 for great intellect, $285,000 for great talent, and $259,000 for eternal truth. I made a couple of little notes to the side that I'll talk about later, but is there a problem in defining these variables of interest? Do people interpret true love in different ways? How about great intellect? There's lots of different things to be intellectual in. It could be in science, music, math, history, or language. Lots of different areas that great talent could cover. Or great intellect. How about great talent? Well, we did just talk about music and languages. Those are talents. How about all of the other talents all over the world? How do you define that? Luckily for us, we as LDS members don't have to pay $259,000 to know eternal truth. All we need is a broken heart, or a broken spirit and a contrite heart. Let's move on to the second example. Statistics said that 10 to 20% of the drugs were stopped from entering the US. Well, let's talk about percent. We talked about the definition of percent. Per means divide, cent, just like 100 cents or 100 pennies in $1, cent is 100. So part of a whole. A percent is part of a whole. So to calculate this percent, it's drugs confiscated divided by all of the drugs entering the US. That's all of the confiscated and the not confiscated. If we don't know all of those that were not confiscated, how can we give it a percent? And if we did know of all of the drugs coming into the US, then why didn't they confiscate all of them? So we don't know the whole total, and so that statistic is not correct. Although I do understand that they can estimate, but still very not accurate. Guideline number 5. Watch out for confounding variables. Radon is the decay of uranium leaching into buildings and causing lung cancer. Unfortunately, my state of Colorado has very high radon levels. Hong Kong, however, has very low radon levels, but the percent of lung cancer is the same in Colorado and Hong Kong. So we can conclude that radon doesn't affect lungs. The confounding variable here is that Hong Kong has a very high smoking rate, and that radon does indeed cause lung cancer. Our second example is in my notes from instructor. Ice cream sales in New York increase at the same time as crime rate increases. Well, let's talk about what happens when ice cream sales increase. Ice cream sales increase in the summertime when it starts getting warm outside. So the same time, crime rates are also increasing in the summertime. We can't conclude that ice cream creates criminals. There's a confounding variable of heat. Why would crime rates increase in the summertime? We can brainstorm, and I'm sure you have come up with some of your own ideas of why that might occur. But a couple of things that I thought of were, In the summertime, people leave their windows open because they want to cool their apartments down or hopefully have a breeze come through. Also, in the summertime, people are more likely to walk around instead of getting into a cab or driving or taking a bus because it's warmer versus in the wintertime you're going to want to drive. And so they're more available to be mugged. So the confounding variable is heat or the summertime. Guideline number 6. Consider the setting and wordings in surveys. When the following question was asked and the order was changed, the results changed as follows. Would you say traffic contributes to air pollution more or less than industry? When traffic came first, there was a 45% saying that traffic contributed more and industry was 32%. In just switching those two words and putting industry first, it actually, as you read it, kind of subliminally tells you industry contributes to air pollution more or less than traffic, and it was a 57% to a 24%. Let's move on to number 2. Do you favor a tax cut? 67% who answered this question said yes, but they weren't given other options, kind of like an experiment versus a control group. You need to have some options when asking questions, such as, would you like to use the surplus to pay for Social Security, the national debt, or a tax cut? In giving these other options, 26% was actually the highest, and they said they'd rather pay the surplus to a national debt. Let's move to guideline number 7. Check that the results are presented fairly. There are things like misleading graphs or bias. Our first example comes from Boulder, Colorado. The school board stated that 28% of children are reading below grade level. However, what occurred is 28% didn't really score below grade level but below national average. And they didn't state the 72% scored above the national average. And grade level is not necessarily national average. Our last guideline, guideline number 8. Consider the conclusions. Did the conclusion of the statistical study achieve its goals? Does the conclusion make sense? Does it rule out alternative explanations for the results, like confounding variables? Also, does the rule have practical significance? For our next example, a fast diet supplement versus losing weight other ways. After 8 weeks of treatment, those who were in the treatment group lost an average of half a pound more than those in the control group. Well, half a pound is hardly significant. If you're on an analog scale, you can probably not even barely see what the half a pound is in between the two little tick marks. So, does it have practical significance? No. That's guideline number 8. I hope to see you for section 5C.